In this video, I'm going to review the wiring information that's been provided to you in the project for clarity. And in subsequent videos, we'll look at how you can create your schematics and PCB designs. So one of the documents that's available on the Brightspace page and on the L drive is the wiring to sensor head. There are 4 separate sensors in our system. And while this hasn't quite been updated, the pressure sensor does still take the same signals, or same power supplies and provide the same signals. So this will remain the same. So for wind direction, you have 3 connections, an output voltage, 5 volts and ground. For pressure, you have 5 volts and ground, and you have 2 output voltages, and we're going to measure the differential between the positive and negative output voltages. For the HTM 1735, it takes 5 volts and ground, and it gives you a resistance value and a humidity voltage. The wind speed takes 5 volts and ground. This one requires a pull-up resistor between 5 volts and signal, and this is my output signal here. And so that's the 4 sensors. And how do you figure out which pin is which? You go to the sensor specification sheet. For the compact DAC schematic, this is giving you just a little bit more information, including which DAC unit is appropriate for each signal. So here's my 5 volt power supply. That's a cord that comes out of your USB port on the computer. And on your board somewhere, you're going to include a capacitor with 1 microfarad of capacitance. This is just to even out the power supply. So that'll make the power supply to the board a nice even 5 volts. The thermistor is on the HTM 1735, and this sends a resistance value to my 9219 and requires a ground wire. My humidity sensor takes 5 volts and sends voltage to the 9205. Ground has to go to the 9205. Ground will also go to the 9219. And ground is a common, so you only have to wire this once. So the 9219 gets 1 ground. The 9205 gets 1 ground, even though the 9205 is taking multiple signals. Okay. You will notice a resistor here between the thermistor and the 9219. That's because at cold temperatures, this might be as big as 30,000 ohms, and 9219 maxes out at 10. It can't see larger than 10K. So we need to put these in parallel to reduce the resistance to the DAC. That means you have to do some math before you can get your resistance out of the 9219 that results in a thermistor value. So you can't measure temperature directly using this because of the resistor here. What else? Let's see. We have the wind direction, takes 5 volts, takes ground, sends a voltage signal to the 9205. The pressure sensor takes 5 volts and ground, sends 2 signals to the 9205. And then this one uses the 9401. This is your optical switch for the anemometer. Has a pull-up resistor for the signal side of things. That pull-up goes to 5 volts. And we have ground coming to the sensor. And the 9401 is going to take ground and signal on the other end of this 22K resistor. So that explains these schematics, and that concludes this video. If you have questions, post to the discussion board, send me an email, or bring them up in class.